Welcome to
KidMath number 118.
KidMath number 118. So this morning we've been on section 17.2 of Art of Problem Solving's algebra book, and we're talking about transforming functions. And we've talked about a lot of different transformations, adding and subtracting, and then bringing numbers inside the function too, like f of x plus 2. So here we're going to look at f of 2x. Okay? So, sorry to go quick, but that's what we have to do for our movies sometimes. So we'll consider the function f of x equals x squared plus 1. Okay. What can you tell me? What sort of shape is this?
This is a parabola.
Okay, how do you know that?
Well, it's a quadratic equation. We have the x squared in it.
Okay, it's a quadratic equation and it's a parabola. This happens to be a relatively simple parabola. What does this look like?
Well, it starts at y equals 1. And it kind of goes up.
Like that. Okay. So for purposes, that's good. This looks like the parabola y equals x squared shifted up by 1, right?
Mm-hmm.
For purposes of what I'm going to try to do here, I need to make this just a little fatter so that we can graph this function too. So I'm just going to make it just a little wider like that. So we have a parabola that looks like that. Okay?
All right.
All right, now we're going to consider this function, the graph of this, y equals f of 2x. Okay, and I'm just going to make a quick little chart, x, 2x, and then f of 2x. And this is where the function is x squared plus 1. Okay, so I'm just going to go minus 3, minus 2, minus 1, 0, 1, 2, 3. 2x would then be what? Read down for me.
It would be minus 6, minus 4, minus 2, 0, 2, 4, 6.
Okay, and what is f of minus 6, where the function f of x is x squared plus 1? What is f of minus 6?
It's 37.
37. What's f of minus 4?
17.
F of minus 2?
F of minus 2 would be 5.
F of 0?
1.
F of 2?
5.
F of 4?
17.
17.
And 37.
And 37. Now let's compare this to what our graph here. At 3, the graph of f of x, where was this at 3 when x equals 3?
It's at 10.
At 10.
This is much steeper.
So we're at 37 now for 3. So this function is going to come in. It stays the same. It's 1 when x equals 0. But it's much steeper. Okay? It goes up very quickly. Okay? Our function when x equals 1 was where? This function x squared plus 1 when x equals 1?
When x is 1, it's 2.
2. And our new function's up at 5 already. Okay?
Yeah.
Now, what I want to explore here is a little bit of the geometry. I'll just erase this. How can I tell, what's a clue that you have for these two functions? That this is y equals f of 2x and not y equals 2f of x. Okay, how can I tell the difference between this function, which is f of 2x, just by looking at this graph, and 2 times f of x? This is kind of a little bit of a challenge problem for you.
Well, this is the points on the y-axis. It is this f of x part. So this function multiplies the y values by 2.
Okay, very good. This function multiplies the y values by 2. This function does something, it kind of smashes it in and makes it steeper. What point on the graph here makes it obvious that this steeper graph is f of 2x and not 2f of x?
Well, there's this point.
What is that point?
This is 0, 1.
0, 1. Okay, where would 2f of x be? Remember, f of x is x squared plus 1. Where would 2f of x be?
It would have to be...
At x equals 0, I mean.
At x equals 0, it's 0.
What's f of x? What's our function?
It's x squared plus 1. It's 1, it's at 2. Somewhere here.
2f of x would be at 0, you'd get 1, then you'd multiply it by 2, so it'd be up here. Okay? So you can see right away that there's a difference between f of 2x and 2f of x, at least for this function. Okay? So that's what I wanted to show you. Bringing the constants on the inside is pretty interesting. For now, to understand this, it's good to make a chart, graph a few points, and just see what happens. Okay? All right. Good job, sweetie.